Welcome back to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Menegra, and in this video today, we are going to look at reporting a linear regression. So this is in the results section of a thesis, and this is where we're going to look at how to do the write-up for a linear regression, and also how to use a linear regression for predictions for future events. So if we go back to the empirical cycle of research, we know that observation is where we get our background information and the creation of the hypothesis. The induction, we're formatting the hypothesis. Deduction, we're transforming the hypothesis into a prediction. Now we have to test the hypothesis. So in the results section, we're reporting the testing. And after we report the testing, then we can evaluate whether the results answer or whether the hypothesis is confirmed or whether it is provisionally rejected. And so a linear regression, when would we use a linear regression? So a linear regression would be used to show a causal relationship. A causal relationship we would also see with a correlation. However, with a linear regression, we get a lot more information. Also, we would use this for forecasting an event and for trend forecasting. So in this image here, we can see the line of R and the correlation, which is in red here. And for forecasting, we would use a regression equation to predict future events. In the previous video, I used y equals b plus mx, but in this video, we're going to use the same formula. I've just changed a couple of the letters to y equals a plus bx. So to show the causal relationship, you would need the ANOVA table and the value of R, which is the information in the purple rectangle on this slide here. We've got the ANOVA table and the value of R right here. You would also want to use the partial regression plot. So if we go under the residual plots or plots in JASP down to partial regression plot, you can have this with the confidence intervals at 95%, which are these light blue lines here, and the prediction intervals with the dark blue dotted lines as well. The prediction intervals are going to tell us, okay, if there's new data that's going to be introduced into this data set, it will tell us that that data should essentially fall between these thick blue dotted lines. So when you're pulling up the plot diagram, you can show the regression, or you can also show the confidence intervals and prediction intervals on the diagram, but you would want to explain what the confidence intervals and prediction intervals are. Now, for the write-up for a causal relationship, if you're only using the linear regression to show the causal relationship, you're going to write this up similar to an ANOVA. So as an example, a linear regression was performed, which showed the hours studied significantly predicted the student grade. In this case here, the data set that I'm using is the student grades versus hours studied. And here we have the F value, F135, which are our degrees of freedom over here, equals 63.41, which is our F statistic, and the p-value is less than 0.001. The correlation between hours studied and grade is statistically significant. So we have R35, 35, again, our degrees of freedom, and R is 0.803, which we have up here. And the p-value again is less than 0.001. Now, remember, R is the line that goes through the diagram. The line of R is the correlation line. But also, when we look at the line of R, it is also the effect size. So if you remember, the closer that R is to 1, the stronger that it is. So when we look at effect size for R, 0.1 is very weak, so it's a small effect size. Up to 0.5 is a large effect size, but the stronger the correlation, the closer it is to 1. So if we only wanted to look at the causal relationship, we would stop there. But if we want to do a write-up for forecasting, then we're going to continue. So if you want to do forecasting, first thing you're going to need are to grab the descriptives. So you would just click on the descriptives box. The descriptives will show up right here. And then you would also need the coefficients. So you're going to go to the coefficients and also click on a 95% interval. So we've got the coefficients here and 95% confidence interval here. And so the ANOVA test is going to tell us that the model works. The coefficients are going to tell us how it works. So let's look at how this is going to work here. So first, with the coefficients, there are two types. There are the standardized in the purple box here. And of course, we've seen this number before, 0.803. The standardized coefficient is the same as the correlation. 0.03 is our line of R up here. We then also have the unstandardized coefficients, which are in the black box. And these numbers are scores on the test where the H0 intercept is the mean grade. So if we look here at H0, 72.730, if you look in the descriptives, it is the same. It is right here as well. Okay, we'll continue. So to interpret the coefficients, we need to find both A and B for the regression. So we have A and B on the diagram right here, or in the chart right here, and A is a constant, which is the intercept, or 43.440. So here is A here, 43.440 in the purple box. B is 1.009. So this is a positive number. So in our equation, we're going to use this as a positive. We're going to be adding in the equation. If it was negative 1.009, in the equation, we would be subtracting. So positive numbers suggest the regression will increase. So the line of R goes up, and so the regression is going to increase. So now we need to look at the t-value. In the coefficients, we have a t-value just off to the right with a p-value as well. So if we look down at the bottom, if the t-value associated with B, remember B is 1.009, the t-value across, if it is significant, we can use this as a predictor. If it is not significant, we cannot use this as a predictor. Okay, so this is significant. We can continue. So now, for every 1 unit increase in the predictor variable, the outcome increases by B. Therefore, for every 1 unit increase in the hours studied, the grade will increase by 1.009 points. Okay, we're going to continue with the equations. We'll see how this works. So the equation, again, is y equals a plus bx. So we're going to have to start plugging in those numbers. So y equals a. A, remember from the previous page, is 43.440. B is positive, so we're going to add. So plus 1.009, and x is the number we do not know. So x will be the values of the new data we would want to use in the model. So if a student studies for 52 hours, then x equals 52. Y equals 43.440 plus 1009 times 52 equals 95.91. So if a student studies for 52 hours, according to this particular model, the student's grade should be around 95.91%. If a student studies for 3 hours, in this case, x equals 3. Y equals 43.440 plus 1.009 times 3, and that is 46.48. So their grade would be around 46.48%, according to this prediction model. So how would we do the full write-up then in APA for this linear regression? Okay, so we're going to use both the causal relationship followed by the prediction. And in the text, we have, and I've bolded the numbers and I'm showing below where the numbers are coming from. So the hours studied significantly predicted the student grade. We've got the F statistic. With F, the degrees of freedom 135 equals 63.41. P is less than 0.001, accounting for 64.4% of the variability in grades, adjusted R squared or R2, 63%. If we look down below now, we can see that 64.4% is the R2 and 63% is the adjusted R2. This is a strong or moderately strong predictive relationship. The correlation between hours studied and grade is statistically significant. Now we've got our correlation here. R35 equals 0.803, P is less than 0.001. The regression equation for predicting grades is y equals 43.440 plus 1.009x, or the hours studied. The confidence interval for the slope to predict the grade from hours studied was 95% confidence intervals with a B 1.009. Thus, for each 1 unit of increase in hours studied, the grade increases from 0.8 to 1.3 points. 0.8 and 1.3 are the confidence intervals at 95%. So you can pull that right off of the confidence interval portion of the chart. That's where we're getting that number from. So this is how you would do the full write-up for the linear regression, which includes the forecasting. Additionally, you would want to include the graph in the write-up, in the thesis, or in the article. So thank you so much for watching this video on how to do the write-up of a linear regression, and I look forward to seeing you in the next video.